All right, so this is the test 2 review video. Make sure that you've actually worked through this review and that you're not just watching this video without having done the work yourself. It's going to mean a lot more to you if you've worked the problems, and then you can just kind of skip ahead to the questions you weren't quite sure about. There are two forms for a quadratic equation that we discussed. One is called the vertex form, and that's actually the form that this is. And the other is called the standard form, which is the more common ax squared plus bx plus c format. But when a formula looks like this in the vertex form, the vertex is very simple to pick out. So when it looks like parentheses squared and then minus a number, you just change the sign of the first number and you pull this number out. Okay, so the formula actually is, just so you know, I'm going to write it kind of under. The formula format is basically x minus h parentheses squared and then plus k. So notice, because of this minus sign, that's why we changed the sign of this number. Okay, so if you have an equation in vertex form, it's called vertex form because you can easily pull the vertex out without really doing too much work. But when you have a squared equation that looks like number 2, by the way, this is standard form. This is how you're going to see squared equations written most often. Okay, notice it's ax squared plus bx plus c. So when it's in this form, you have to have a formula for vertex. You are going to need to know this formula. So to find the x, you do negative b over 2a. And then to find the y, you're going to plug in that value you just got. Okay, so for this problem, we would do x equals negative 6 over 2 times 1, which is negative 3. And so to find the y, we would do f of negative 3. In other words, take the negative 3 and plug it in the given equation. So we're going to get 9 minus 18, which is negative 9, plus 8, which is negative 1. Okay, so the vertex, and I want to see it written as a point because that's what it is negative 3 comma negative 1. Okay, note that this problem also asked you for the axis of symmetry. Remember, that is the line that, the vertical line that cuts a parabola in half. Okay, and it always runs through the vertex, so it's a vertical line, so it looks like x equals something, and then you just pull the x value out of the vertex. So if you have the vertex, you actually get the axis of symmetry for free. And then I want to find the x-intercepts. We always do that by setting x equal to 0. And we'll also find the y-intercept by setting x equal to 0. So anytime you want either type of intercept, you just set the other thing equal to 0. So let's start with x-intercepts first. So remember that you can have more than one x-intercept. You can never have more than one y-intercept because then it would fail the vertical line test. So I'm looking for, notice I don't really even need AC method here. I just need factors of 8 that add up to 6, and those are x plus 4 and x plus 2. So then I set each part equal to 0. So I end up getting negative 4 and negative 2. So in general, I do want you to write these as points. So it's going to be negative 4 comma 0 and negative 2 comma 0. Okay, so note we have two x values, right, and the y value is 0 for both of those. For the y-intercept, it's often a little easier. I just need to plug in 0 for x. So I just need to find what's 0 squared plus 6 times 0 plus 8. And of course, it's 8, right? So you might see it as y equals 8, but more than likely I'm going to, again, want you to write it as a point. So we'll say, hey, it's the point 0.8. Okay, so let's see if we can graph all of this information. So I'm going to go up 8. Okay, so I'm going to plot my y-intercept there, and then I need to go out at least 4 for the x-axis because my x-intercepts are negative 4 and negative 2. And then I also need to mark the vertex. Actually, the vertex is one of the more important points because it tells you where you're going to make a turn. Okay, so here's the vertex. So I like to write myself a little note that, hey, I need to make a turn right here. So essentially I've got this parabola. Notice I'm drawing it from the vertex out. So plot your vertex and then go both to the left and the right with it. All right, so let's talk about number 3, the leading coefficient test. It's been a while since we talked about this, but the leading coefficient test tells the end behavior of a graph. And it does that by looking at the degree, okay, whether that is even or odd, and the leading coefficient, whether that is positive or negative. Okay, so if you don't remember doing this, you might need to look this up, but this was 4 cases. Okay, it all had to do with what we could expect the graph to do at the far left and the far right. That's what end behavior means. So in this case, the leading coefficient is 11, which is positive, and the degree is 3, which is odd. Okay, so the significant parts of this are not really the numbers. It's the fact that I have a positive leading coefficient and an odd degree. So what that tells us then is that the graph rises to the right and falls to the left. Okay, so you will need to know the 4 cases because I'm not promising that the one that you will be asked about on the exam will be this case in particular. But remember, like, if this is what happens when you have a positive leading coefficient and an odd degree, then a negative leading coefficient and an odd degree would be the opposite of this. So we would rise to the left and fall to the right. And then remember, if we have an even degree, the graph goes either up or down in both directions. If it's positive, it goes up in both directions, and if it's negative, it goes down in both directions. Okay, so there are 4 cases to remember, but I think you can handle it. Okay. In fact, if you know a couple of them, you probably know the negative versions kind of for free. So we talked about that originally too. All right, so for number 4, I ask you to find the zeros and then the multiplicity of each. Okay, so just remember that 0 is just another name for a root. Okay, it can also be an x-intercept as long as it's a real number. So these 3 terms are used interchangeably, but just know that a 0 or a root that is imaginary wouldn't also be an x-intercept. It would not be because we wouldn't be able to graph it. Okay, so when you're asked to solve g of x equals x cubed plus 4x squared plus 4x, you're really trying to find where y is 0. Okay, because notice when we find the x-intercept, we set y equal to 0. And what I hope you notice right off the bat is that we could factor an x out. And if we did, this would be much nicer to kind of factor / deal with, right? So what we end up getting, again, you need to be able to factor pretty efficiently by now. That's why we go over those things the first week of class. Okay, so we expect that you can factor. And so notice now I have it fully factored, and so now I can set each part equal to 0. So I get x equals 0 and x plus 2 equals 0. Here, notice this x only occurred once, so the multiplicity is 1. Okay. Here, though, you're going to get x equals -2, and notice that parentheses occurred twice. Okay. So in this case, the multiplicity is 2. Remember that when you add your multiplicities up, you should get the total degree of the polynomial. So notice if you add 2 and 1, you get 3, which was the degree of the original polynomial. So we're good there. All right, number 5, same thing. So x cubed minus 9x, and we're going to set that equal to 0. So again, I would hope that you would notice, hey, they both have an x. So I'm going to factor out an x. Okay, but when I do, I get a difference of squares, right? So this factors hopefully quickly. So notice now it's fully factored and I can set each part equal to 0. So x equals 0 and x plus 3 equals 0 and x minus 3 equals 0. So here I get x equals 0 again. If you look back up here, notice it only occurs once. So the multiplicity is 1 here. This will give us x equals negative 3. This specific x plus 3 thing only happens once, so the multiplicity is also 1 here. And then here we're going to get 3, and again this one only occurs once. So for the multiplicity to be more than 1, it needs to be exactly the same parentheses repeated like this one was up here. But notice these are two different ones, right? One is plus 3 and one's minus 3. So the multiplicity of each of those is 1. And again, notice 1 plus 1 plus 1. If you add up all 3 of those multiplicities, you get 3, which is the degree of the whole thing. Okay, so let's talk about number 6 and 7. Okay, so I'm trying to let you know that those following problems might be worth double on the test. Okay, I might have 2 different questions where you do half of the problem in one question and you work the other half, but these questions are going to be worth more points because frankly there's a lot of work to show for them. Okay, so we're going to kind of run through the list of things that I ask. So I ask you to graph it by finding the following things, and we're just going to literally cover every one of them. So first, let's write down the equation so that we can have it to look at. So the first one is x to the 4th minus 4x squared. So first I want you to tell me what the end behavior is. Okay, so on the test I would expect that you have something for everything that I asked for. So remember the end behavior, we just kind of did that one back in, what, number 3? Okay, but notice the leading coefficient is 1, which is positive. The degree is 4, which is even. So that means the graph goes up in both directions. So the graph rises in both directions. So this is that 4 cases thing, so you might need to look that up. All right, so end behavior, now let's find the y-intercept. Okay, to find the y-intercept, we always set x equal to 0. So we would do f of 0, which is 0 to the 4th minus 4 times 0 squared, but that's just 0, so we would get 0, 0 there. For the x-intercepts, remember we would set y equal to 0, so we would say 0 equals x to the 4th minus 4x squared. So kind of like the previous 2 problems where we just focused on the x-intercept, right? See if you can factor anything that they have in common. So they have an x squared, and then you're left with x squared minus 4. But then this factors into x squared, and this works out to be x plus 2, x minus 2 again because it's a difference of squares. So I end up with 1, 2, 3 different parentheses to set equal to 0. So here I get x equals 0, which has a multiplicity of 2, right? Notice there's a squared there. Okay, so the multiplicity is 2, which is even. So it does tell us something about the curve, right? It tells us that the graph turns. So I'm asking for more information on this one than I was on the previous number 4 and number 5. I'm asking what's going to happen at the graph or for the graph. And then notice I get x equals negative 2 for the middle parentheses, right? The multiplicity of that one is just 1. It just occurs one time. But that's an odd multiplicity. Okay, so it means the graph goes through or crosses. I don't care how you say it, as long as it kind of makes sense to you. And then last but not least, we get x equals 2 for the last one. Again, the multiplicity there is 1, which is odd. So the graph crosses. So here is where, remember, we graph what we have and we see where we're at, right? So we graph all the pieces we know, and then we ask ourselves, you know, is there still some things that I'm not quite sure about? So I'm going to go out 4 in every direction. So I gave you a little graph that you could mess with on the review itself. Okay. So we're going to mark the points that we know, right? We know that it crosses at 0, 0. Okay. We know that it has x-intercepts at -2 and 2. But we know something even more maybe helpful, right? We actually know that here we're going to cross. Here we're going to cross as well. But here we're going to turn. Okay. And we also actually know that the graph goes up in both directions. So we can go ahead and show the end behavior with our arrows there. So the real question kind of is like, how far down do I go here and here? That's really where I don't know about. So the additional points really can only be determined kind of what you need when you graph what you already have. Okay, so for this, you're allowed to pick as many additional points as you would like. Okay, but I certainly think it would be helpful if we knew what was happening at -1 and 1. Okay, because that would fill in these blanks right here. So what we do to find these y values, remember, is we plug these into the original function, into f of x. So we're going to do -1 to the 4th minus 4 times -1. And so we can use our calculator if we need to, but it's basically just 1 minus 4 or -3. Same thing here, if you plug in 1, and again, I'm just plugging it into this guy, this equation. Okay, if I plug in 1 to 1 to the 4th minus 4 times 1 squared, I also get -3. Okay, so notice I'm going to get rid of these question marks here because they're kind of in my way. So I'm going to have the point -1, 3, which is here, and then 1, 3. And then make sure you make curvy kind of transitions. So it should be like a W-ish shape. It should not be jagged edges. Polynomials, all polynomials have smooth, curvy graphs, so it should kind of look like that. Okay. So let's look at number 7, same kind of thing. So f of x equals x cubed minus 4x squared plus x plus 6. So let's run through the list of things we're supposed to find. So for end behavior, we need two things, right? We need to know what the leading coefficient is, okay, or really what the sign of it is. It's positive. And we need to know what the degree is, or at least whether it's even or odd. Okay. So that tells us that the graph goes up to the right and down to the left. So it rises to the right and falls to the left. Okay. For the y-intercept, we're going to set x equal to 0. So we're going to find f of 0. So we get 0 cubed minus 4 times 0 squared plus 0 plus 6. So you end up just getting y equals 6, or the 0.06. So I'm going to circle that. As far as the x-intercepts go, we would set y equal to 0. So this one's a little tougher. Okay, because notice I don't really necessarily know how to factor this guy, and so I might need to do a little more kind of thinking here. Okay, so if I want to try to factor this, this is where you have to try to list the possible zeros, and we're actually going to cover that a little bit later also. And so I'll go into detail about this when we get to number 11, but the possible rational zeros that we could come up with for this problem, since we don't really know how to factor it, would be the factors of 6 over the factors of 1. It's the factors of the last number over the factors of the first number. Okay, so we're going to get a bunch of choices here. We're going to get plus and minus 1, 2, 3, and 6, because those all go into 6. And then we get plus and minus 1 on the bottom. So notice this 1 doesn't really change anything, so I end up getting kind of 8 choices to try. But let's say I don't really want to lazily, you know, I don't want to try all of those, right? I don't want to try all 8. So I'm going to use, we talked about this in class, but I'm going to use my calculator to kind of hone in on the ones that I should maybe pay more attention to. So let's enter it in. X cubed minus 4x squared plus x plus 6. Okay, so let's graph it. Let me see if I can get it out of the glare. There we go. So if you look at it, it looks like it crosses at -1, 2, and 3. Okay, so just pick one of them. It really doesn't matter which one. So I am going to try -1 first. And remember, this is how you try it. You do synthetic division, and you see if you get a remainder of 0. Okay, so you bring down the 1. 1 times -1 is -1. Add those, and you get -5. -5 times -1 is 5. Add those and you get 6. 6 times -1 is -6. Okay, so -1 is a 0. Okay, by the way, just before we move on, remember that this actually represents x plus 1 because we changed the sign. But then the point is we get something left over, so we get x squared minus 5x plus 6. And then I think we could factor this further. This would be x plus 6, and this would be x minus 1. So what you end up getting then is that our function f of x factors into x plus 1 times x plus 6 times x minus 1. Actually, that's not right, is it? So be careful, and I didn't really do that on purpose. You just want to be cautious, right? The signs here aren't right, so what I actually should have done is a -2 and a -3. So I was just being hasty about it, honestly. So this would be x plus 2, and this will be x minus 3. So don't make a goofy mistake like that. Make sure it actually factors right. Remember, the point of this was to set this equal to 0. Okay, it's just taking me a minute because it was an x cubed equation and I have to work out a little bit more stuff. So I end up getting x equals -1 and x equals -2 and x equals -3. Okay, I don't want to go into it for all of them, but let's just do this. The multiplicity of each of these is 1. So it means that the graph crosses for each of them. Okay, so let's fit the graph in here. So we'll go out 6 in every direction, since I know we have a 6. So let's graph what we know, right? We know that it crosses the y-axis at 6. We know that it crosses the x-axis at, gosh, I'm just going to have all kinds of mistakes on this one, so sorry about that. You can adjust this, though. So this should have been a -2 and a -3, right? So let me fix that. I just was trying to quickly adjust it, and I didn't adjust it right, basically. So back up here, rewind, okay? This should have been an x -2 and an x -3 because they have to add up to be -5. Okay, so actually the roots should have been positives here. So I end up getting 2 and 3. Okay, so just make sure you go back and erase that and change that. Okay, so I'm sorry I made that mistake there. So we know that the graph goes up to the right, and we know that it goes down to the left. And we also know that it goes through every time, right? So I even think we kind of know what it does here, right? The question really is like, what is this value, right? So what is this value right here? Because we know we're going to have to come back here, right? So I'm going to put question marks by kind of where we'd like to know. We'd probably like to know what's happening there, and it'd probably be helpful if we knew what was happening in between 2 and 3 also, okay? So when we get to the additional points section, you don't have to pick a crazy number of them, but you can honestly pick as many as you want. You just need to pick kind of where your gaps in the graph are, right? And I think we have a gap at 1, and I think we have a gap at 2.5. Okay, so you can use your calculator for this. You're just going to plug these in to find your y's. So let's do that. I'm going to show you what that looks like. So you're going to do 1 cubed minus 4 times 1 squared plus 1 plus 6. Okay, so I get 4 here. And then let's figure out what 2.5 gives us. So 2.5 cubed. And by the way, I'm plugging it into our original f of x equation, right? So if you wonder where I'm getting that from, that's where I'm getting it from. Plus 2.5 and then plus 6. Okay, so notice you don't go down very far, right? Negative 0.875 is just a little bit under 1. So let's go ahead and graph these points, and then I think we'll have a really good idea of what the graph is. So 1, 4 is here. Okay, so I'm going to erase my question marks here so that they're out of my way. And then I've got 2.5 and then almost to 1, right? And then it's just a matter of like connecting your dots, right? So the graph looks something like this. Okay, so really important that you choose the additional points based on where the spaces are in your graph that you're just not quite sure about still. Okay, and then just make sure you don't make errors like I did over here, right? So I was just having some brain farts with factoring there, so just try not to do that. Okay, so those problems possibly will be worth double because notice they take a lot of time, right? There's lots of different pieces, and so you need to make sure that you could show all the pieces there. All right, so number 8, we're going to use long division. Remember, long division works very similarly to the way that long division with digits and numbers used to work in elementary school, right? But this is definitely not an elementary school problem, right? Because we're dividing 3x squared minus 2x plus 5 by x plus 3. So one trick, remember, is to focus on the first terms only when you're trying to decide what you get. So look at the first terms. Okay, so we're going to look at these two, and you're going to ask yourself, what would happen if you divided x out from 3x squared? And the answer is you would get 3x. So I'm going to line that up with its like term. And then what you're going to do with this is you are going to multiply. I'm going to put a parentheses around here. You're going to multiply down, and you're going to figure out what you get. So do 3x times x, which is 3x squared. And then you do 3x times minus 3, which is minus 9x. And then you subtract. So I'm using a different color to kind of show what we're changing here. So notice that's gone. And then we're going to get 7x. And then we're going to bring down the next term. So we're going to bring down the plus 5. And then we're going to do the process all over again. Again, we only pay attention to the first terms. So now I'm going to compare x to 7x, and I'm going to ask myself the same question. What if I divided an x out from a 7x, and I would get a 7, right? So by the way, you are done with the 3x. You don't worry about that. But now you're going to do 7 times x, which is 7x. And then 7 times the negative 3, which is minus 21. And then you are going to subtract, which changes the signs. Okay, notice the first term in every step should always cancel out if you've done it right. But then in the end, you get 21. Notice that I couldn't go any further, right? I can't pull an x out of a 21. Okay, so this becomes my remainder. So the answer is what you get on top, and then plus whatever remainder you have over what you were dividing by. Okay, if the remainder is 0, then you don't have to have that remainder term. Okay, so let's try another one. So we'll divide by x squared plus 3x, and we're going to divide into x cubed minus 2x squared minus 5x plus 6. Okay, so once again, only look at the first terms and ask yourself, if you divided an x squared out from an x cubed, what would you have? And the answer is you would have x. So once again, we are going to take this and we are going to multiply down. So x times x squared is x cubed. X times 3x is 3x squared. I always write down what I get when I multiply, and then I come through and change the signs. So that's gone. Okay, and we're going to get negative 5x squared. And then we have more terms to carry down, so we're going to bring down the next one. And then we're going to do it again. Okay, so again, we're going to say, what would happen if I divided out an x squared from a negative 5x squared? And the answer is I would get negative 5. So negative 5 times x squared is negative 5x squared. Negative 5 times 3x would be minus 15x. And then we're going to come through and subtract, which changes all the signs. So this is gone, and we've got 10x here. Don't forget to bring down your final term. But as far as doing it again, we can't do it anymore, right? Notice if you tried to pull an x squared out of a 10x, you can't. So all of this is actually the remainder. And so you're going to get an answer of x minus 5, and then plus the remainder you got, which, yes, I know it's not so pleasant, divided by whatever you were originally dividing by. Okay. So definitely make sure you know how to do synthetic division, or sorry, long division. I assume that you probably prefer synthetic division, and that's fine, but you need to make sure that you also know how to do long division as well. All right, number 10. So number 10 is using synthetic division. Remember that synthetic division is only for x plus or minus c divisors. It doesn't work when you're dividing by something more complicated than that. Okay, so notice on number 8 and 9, you could have done this one using synthetic division since we were just dividing by x minus 3. You could not have done number 9 using synthetic division. So just keep that in mind. So what synthetic division looks like, remember, is you change the sign of what's in the box. Okay, and we actually already did one like this earlier. So you will have at least one problem where you have to use long division, and then another problem where you have to use synthetic division, but then from there on out, you'll probably get to choose which one you use. So bring down the 4. 4 times 1 is 4. Add the column and you get 1. 1 times 1 is 1. Add that column and you get 4. And then 4 times 1 is 4. Add that and you get 15. Make sure you know how to kind of write the answer, right? This is the remainder. This is the constant, the x squared. Okay, so I don't just want you to do synthetic division. You're actually supposed to write your answer once you're done. So 3x squared plus x plus 4, and then you're going to write the 15 over the original thing you were dividing by. And sorry, you were originally dividing by x minus 1, right? Which is why we changed the sign to plus 1. All right, so let's look at number 11. So I told you that we would go over the rational zeros theorem a little bit more, but the rational zeros theorem just says that the rational zero possibilities are always factors. It's always factors of Factors of the last number, so factors of the constant over factors of the leading coefficient. So for this one, I think I've got a typo on my review, so I'm hoping that I have the right number here. So for number 11, it is supposed to read plus 16. Okay, so I'm not really sure necessarily if that's what y'all have, so we'll change it if we need to, because the one I have isn't that number for some reason. So basically the possible rational zeros would be, so I'm just going to say the possibilities are going to look like factors of 16 over factors of 2. So list the factors of 16. 1 goes into 16. So does 2, 4, 8, and 16. And then the factors of 2 are 1 and 2. And then what you need to make sure you do here is list them all. Okay, so the possibilities are going to be all of these numbers over 1, but then also all of these numbers over 2. Okay, so I'm going to do all the numbers over 1 first. Because, I mean, those are easy, right? We already actually have those written down. Notice I'm including positives and negatives, right? Because negative numbers are factors of, for instance, negative 16 also. So I did 1, 2, 4, 8, and 16 all over 1. But now I need to do 1 over 2, right? And then I've got 2 over 2, but that's just 1, so I don't need to write that. 4 over 2 is just 2. I already have that. 8 over 2 is just 4. I already have that. And then 16 over 2 is 8. Okay, so we end up getting these possibilities. Okay, so note that this is actually 12 possibilities. Okay, it's 6 numbers, but it's the positive and negative versions of each. Okay, so that's still a lot of things to try with synthetic division, but at least it's not, you know, a shot in the dark. You have at least a list to look at. All right, so let's go through 12 through 14. Okay, first you're supposed to list the possibilities, so we're just going to do that real quick, and then we're going to talk about which ones work. So the possibilities for g of x on number 12 would be the factors of 20 over the factors of 1. So it's just going to be 1, 2, 4, 5, 10, and 20. And then notice the first number is just 1. Okay, so it's basically just all of the top numbers. So that is still a lot of choices to try. So what we do in this, and remember what I told you I would probably do, is I would give you a hint about where to start. So we're going to use the calculator basically. To know where to start. But on the exam, I'm going to actually tell you where to start. I'm going to be like, here's a function, and here is where I want you to start as far as zeros go. So let's go x to the 4th minus 7x cubed plus 14x squared plus 2x minus 20. So we're going to graph that. So it looks like -1's a good choice, and it looks like 2, right? So I'm going to try x equals -1 and x equals 2. So again, on the test itself, I would probably say, here's where I want you to start so that you would kind of know, okay? It doesn't make a difference which one we start with, right? So I forgot to write the function down, so let's go ahead and write it down here. X to the 4th minus 7x cubed plus 14x squared plus 2x minus 20 is the function. Okay. So let's try -1 first. Okay, don't forget that when you do synthetic division, if you skip any points, you need to make sure you put zeros in the place of that value. But we didn't skip any values of x, right? We went straight from 4 to 3 to 2 to 1. So I'm going to do synthetic division kind of quickly because we should be pros at this by now. So we're adding down the columns and we're multiplying this times this number. Okay, so notice we get 0, right, which is what we want. When the remainder is 0, it tells us that the original function must have been an x, or an x-intercept. So -1 is a 0. We are also going to be factoring this, so make sure that you know that this is actually x plus 1. And so what we end up getting here, let's go ahead and write it, is x cubed minus 8x squared plus 22x minus 20. So I found one 0, right? But I've still got another one to try. And remember what we do, we always use the reduced list. For the second 0. So when I go to try 2, which I also figured on my calculator was right, we're going to use these numbers. So 1, -8, 22, and -20. Because the point is actually to slowly reduce the equation as I go. So bring down the 1. 1 times 2 is 2. Add that and you get -6. -6 times 2 is -12. Add that and you get -20, which is 0. Okay, so just like before, right, this is my remainder. So that means 2 is a 0. Also remember that that means that x minus 2 is actually the parentheses that will factor into. But then notice what we have. We have x squared minus 6x plus 10. Okay, so basically we have 2 more zeros that we can find here. Okay, the point of doing synthetic division kind of with this process is to get it down to a squared equation. So I'm just going to say there are 2 more zeros here. I just need to figure out what they are. Okay, and I can do that either by factoring or I can use quadratic formula. So I'm going to set x squared minus 6x plus 10 equal to 0. Okay, but notice that this doesn't factor. And when something can't factor, we have another backup plan. We have a plan B. So we're going to use quadratic formula. So let's set that up. We should know how to do this. Okay, we should know how to do quadratic formula. So it's -b plus or minus the square root of b squared minus 4ac all over 2a. By the way, I didn't mention it, but the reason this doesn't factor is there are no factors of 10 that add up to -6. Okay, so when that happens, you're not dead in the water. You just go for your plan B, which is quadratic formula. So we end up getting 6 plus or minus, that'll be 36 minus 40. So we get -4 over 2, which actually means we're getting imaginary answers here. So this is going to be 6 plus or minus 2i when you take the square root of a negative number and you just do it like you would normally. So square root of 4 is 2 and then you tack on an I to it. And then last but not least, notice every one of these terms has a 2 in it. So we could cancel 2's out. And that is going to leave us with 3 plus or minus I for these 2 zeros. So there were 4 total zeros. Okay, they were -1, 2, and also 3 plus I and 3 minus I. Okay, notice these are x-intercepts and these are not, right? Because they're imaginary, so they don't show up on the graph. Okay, so that's why if you look back at that graph, we actually only had it crossing twice. And then as far as the factored form goes, you go back up to the top and notice my first parentheses I got to work was x plus 1. The second parentheses I got to work was x minus 2, and then I couldn't factor this out any further, so this is as far as I go with it. Okay, so just to kind of recap, here's where we got -1, here's where we got 2, and then this ugly guy is where we used quadratic formula to get these imaginary answers. Okay. All right, same thing with number 13. This time I'm going to remember to write it out. So x cubed plus x squared minus 5x minus 2. Okay, so the possibilities are factors of 2 over factors of 1. Okay, so we end up having less choices to pick from, right? But again, if you look at the calculator, I'm not going to show you here, but we're going to try x equals 2. So if you looked at your calculator, it looks like it crosses at 2, so we're going to start there. So we're going to try 2. Notice 2 is one of the ones on our list, right? It just means we don't have to go through the trial and error process of trying to find one that's going to give us a remainder of 0. We kind of just jump ahead to the one that we know is going to work. So we bring down the 1. 1 times 2 is 2. Add those and you get 3. 3 times 2 is 6. Add and you get 1. 1 times 2 is 2. Okay. So no surprise, right? The one that we thought would work would, or did. So 2 is a 0. Remember, that means when we get to the factoring step that this is x minus 2. But what I really want to get is x squared plus 3x plus 1. So then we're going to try to find the 2 more zeros at this point, right? Again, this one doesn't factor. There are no factors of 1 that add up to 3. So again, we're going to use the quadratic formula. So we're going to get x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we end up getting -3 plus or minus the square root of 5 over 2. Okay, notice this can't be factored anymore, so I'm actually finished at this point. I got 3 zeros. Okay, I got 1 pleasant one, and then I got 2 that weren't as pleasant. So I'm going to write these separately, but you could also write them together like we did on the last one where you say plus or minus. But I just really want to accentuate that this is 3 answers, I mean. Okay, so notice these are all x-intercepts. It's just that these are not as pleasant, right? These come out to be decimal answers. Okay. And then I think the last thing I asked you to do was factor this, right? So just go back up to the top, right? We had an x minus 2. And then when we divided that out, we got this, and this didn't factor any further, so this is all we can do. Okay, so if you were to look at this on the graphing calculator, you would see that there actually are 3 x-intercepts, but only one that crosses at a whole number, which is the 2. All right, so one more of these. So again, how I probably would ask you on the test is I might say factor this. So I'm just going to kind of edit the question that I have on the review. Find all the zeros if you already know that x equals 2 is a 0. So this is how I'm going to shortcut the test so that you don't have to spend too much time trying to figure out what they are. So if I already kind of give you some guidance on where to start, then you're just going to start right off with your synthetic division. And even though I told you it would work, you do need to go through the process, because the point is not just that it works. The point is that we get a reduced version to find our other ones. Okay, so we did get a remainder of 0, so 2 is a 0, which I already told you that it would be. But what I was hoping to get down to was this right here, x squared minus 2x minus 3. And I'm going to set that equal to 0. And by the way, remember this is x minus 2 when I get to the factoring step. Okay, but this one actually does factor. There are factors of -3 that add up to -2. Okay, so notice it's -3 and +2. Sorry, -3 and +1. Wrote the right thing, said the wrong thing. So you end up getting 2 more, right? X equals 3 and x equals -1. Okay, and notice we're finished, right? We actually have all the zeros now. So the 3 zeros, since I kind of gave you some guidance on what to start with, are 2, 3, and -1. So if you were to graph this, you would see that it crosses at all 3 of these points. Okay, and then as far as the simplifying / factoring goes, it's x minus 2, and then it's these 2 parentheses that I just factored further. Okay. Okay, so let's look at 15. So vertical asymptotes, remember this is how you find vertical asymptotes. You simplify, then set the denominator to 0. So on part A, 3 over x plus 3, g of x equals, that is. Note, we can't simplify this at all, so we just set x plus 3 equal to 0. So you just get x equals -3. Okay, I do want to see it written as x equals because it is a vertical line, so they should look like x equals. Okay, and then we have f of x, which looks like x over x squared minus 7x plus 6. So what we need to do is simplify, or see if we can first. Note this factors into x minus 6, x minus 1, okay, which does not factor or simplify with anything on the top. Okay, so in the end, we just set these equal to 0, so, or the denominator equal to 0, so you just say x minus 6 equals 0, and also x minus 1 equals 0. So you get x equals 6 and x equals 1. And again, write it as x equals. Don't just write the numbers themselves. All right, for 16, for the horizontal asymptotes, okay, you basically compare the powers of the top and the bottom. Just to jog your memory, this involves 3 cases. Okay, if the power on the top is bigger than the power on the bottom, there's none. If the power on top is smaller than the power on the bottom, the horizontal asymptote is y equals 0, and then if it's the same, you just take the leading coefficient of the top over the leading coefficient of the bottom. So, for this one, okay, notice the powers are the same. So that means the horizontal asymptote is going to be y equals, and then you just pull the leading coefficient of the top over the bottom. So it's y equals 15 over 3, or y equals 5. Okay, so it all just has to do with what the powers are. For part B, we've got f of x equals 3x cubed plus 2x over 3x squared. Okay, so notice the power on top is bigger. So what that means is there's no horizontal asymptote at all. If power on top is anything bigger, there's none. And then last but not least, you can probably guess which case this is going to be, since it looks like there's 3 cases and there's 3 problems. Doesn't always work that way though. So notice that the power on top is smaller. So the horizontal asymptote is going to be y equals 0. And on test 2, I might ask you to not only provide me the horizontal asymptote, but give me a brief reason as to why you said that. And your brief reason would be something like this. Okay, just be like a quick sentence saying why you chose the horizontal asymptote that you did. Okay, so 17, find the equation of the slant asymptote and then graph the function. Okay, so the first thing is only functions where the power on top is 1 bigger than the power on bottom, only those functions are even going to have slant asymptotes. Okay. By the way, if you have a slant asymptote, you won't have a horizontal asymptote at all. Okay. So when you look at the function for number 17, it's 2x squared plus 3x over x minus 1. Okay. So notice the power on top is 2 and the power on the bottom is 1, so it does have 1. Okay. And so then to find it, if you determine that it has 1, you just divide and ignore the remainder. Okay, so you can use either long division or synthetic division, it's up to you. Okay, we can use synthetic division here, so that's probably what I would do. So I'm going to put a 1 in the box, but just a little tricky. Notice this is 2, 3, and then I have to put a 0 because it's missing the constant term. So you will bring down the 2. 2 times 1 is 2. 3 plus 2 is 5. 5 times 1 is 5. So I get a remainder, but remember, I don't care here. Okay, this is the remainder, but I'm just going to ignore it anyway. So what I get left here is the equation of my slant asymptote. This is 2x plus 5, so the slant asymptote is literally just that. So I probably will ask you to find a slant asymptote / describe why this function would have one versus another, but I won't ask you to actually graph one that has a slant asymptote. So you just really need to know how to find it. You don't have to know how to graph it. Okay, so I can only video an hour at a time, so for the last 4 questions, I'm going to put it on a second video. So